Section 6.5, more on division of radical expressions. Rationalizing denominators. Sometimes in mathematics, it is useful to find an equivalent expression without a radical in the denominator. And making it so it doesn't have a radical in the denominator is the purpose of this entire section. This provides a standard notation for expression results. The procedure for finding such expression is called rationalizing denominators. We carry this out by multiplying by 1, a special one, meaning a number divided by itself. So let's rationalize the denominator. We have square root of 7 divided by 3. Let's split this radical so that we have the square root of 7 divided by the square root of 3. So we're going to multiply the top and bottom by square root of 3 and square root of 3. Why? Because we have a square root of 3 in the denominator. By doing so, we're left with square root of 7 times square root of 3 and square root of 3 times square root of 3. Notice that square root of 3 is square root of 9, which is 3. So it's technically the same number without the radical. And in the numerator, doesn't matter really what we have. But in this case, we have square root of 21. Now for square roots, this is the only time we can blindly go in and say, oh, I want this number squared. But it's a bit more than that. So let's take a look at this next example. Let's split the radical so that I have the cube root of 7 divided by the cube root of 5. So ideally, or what you should be thinking about in the back of your mind is, what is your goal? What is your aim? Our goal is to have the same number as the index and the exponent. So our goal for this problem would be to have a cube root of 5 to the third power. Here I only have 1 5. What should I multiply the top and bottom by so that I can have 5 to the third power? Well, if I have 1 here, I need 2 more. So it would be a 5 squared. So that we get the cube root of 7 times cube root of 5 squared divided by the cube root of 5, and now we have 1 times 5 squared, 5 cubed. So that we have 5, and in the numerator I can multiply them. 5 squared is 25, and 25 times 7 is 175, the cube root of 175. Let's do one more with radicals. So this is the same thing as the square root of 2a divided by the square root of 5b. Okay, so I want to multiply by a special number such that I reach this number squared. So you want the square root of 5 squared and b squared. I have 1 5, I have 1 b, so I just need 1 more 5 and 1 more b. So I'll multiply square root of 5b to the top and bottom, so that I have the square root of 29 times 5 times b. On the bottom, I have the square root of 5 squared b squared. Now, just as we want, the radical cancels out the squares, so that we're left with 29 times 5, 145, square root of 145b divided by 5b. Remember, your goal is to not have a radical in the denominator. Let's do another one. So what if a number is not prime, such as 9? Is it 9 the same thing as 3 squared? So we want the cube root. We have the cube root of a divided by the cube root of 9x. Well, we already have 3 counted for twice. And remember, your goal in this case is to have the cube root of 3 cubed x cubed. That's your goal. So what special one should I multiply by? If I want 3 3's, I just need one more. I have 1x, I need 2 more x's. So I have the cube root of 3x squared. Then in the numerator, we write the same thing because we're multiplying by a special one. So that in return we get the cube root of 3ax squared. In the bottom, we're just left with 3x. Now, why do I say keep track of your numbers? It's because whenever you have a really big index, like square root of 5. Now here, our radical is only in the denominator. So we want to multiply by a special one so I can get 5 of each copy. I have 1, 2, 2 x's, and 3 y's. So I want to multiply by the fifth root. Remember, you want the fifth root. You have 2xy. You want 5 copies of each. So I have 1, 2. I need 4 more 2's. I have 2 x's. I need 3 more x's. I have 3 y's. I need 2 more y's. You might be thinking, well, I don't know what 2 to the 4th power is. You have your calculator. We can figure it out. In the numerator, I have 3x times the fifth root of 2 to the 4th power x cubed y squared. Then the bottom, we now have 5 of each, so it's just 2xy. All right, 2 to the 4th power, 2 raised to the 4th power gives us 16. So our answer is 3x times the fifth root of 16x cubed y squared divided by 2xy. Now what's the goal? Your goal is to just not have a radical in the denominator. Rationalizing when there are two terms. When we wish to rationalize a denominator that has two terms, and one or more of them involves a square root radical, we multiply by 1 using the conjugate of the denominator. Do you remember what conjugate means? It means same numbers, but different signs. One's a minus, one's a plus. So let's take a look at example 2. We want to rationalize, meaning we do not want a square root in the denominator. To do so, we multiply by a special one, and that special one is the conjugate of your denominator, because your denominator has a square root. All right, so this would be square root of 3 and x, and we have a plus, so we're going to write it with a minus. And that's it. From here, you just work it out. Okay, so let's work this one out. I need to multiply my numerator. So I have 4 times square root of 3 minus x, and we're going to distribute. Now in our denominator, recall your differences of squares. Meaning a squared minus b squared is equal to a plus b, a minus b. Well, here we have the a plus b and the a minus b, so this would be the square difference. So I write square root of 3 and x. Why do you do this? You do this to avoid doing the FOIL method. Okay, so let's go ahead and work this out. So we have to distribute that 4 so that we have 4 square root of 3 minus 4x. The bottom I have 3 squared. Square root of 3 squared is just a 3 since the square and the square root are opposites, minus x squared. That's our answer. Okay, now let's do it again. Our goal is to not have the radical on the bottom. So we multiply by the conjugate, which is same numbers, different signs. So I have square root of 5 plus square root of 2, square root of 5 plus square root of 2. And now in the denominator, we can be lazy. Well, not lazy, but we can take advantage of our past math knowledge. So I have square root of 5 squared minus square root of 2 squared. In the numerator, I have no choice but to FOIL. So I have 4 times square root of 5, 4 times square root of 2, 2 times square root of 5, square root of 2 times square root of 5, and square root of 2 times square root of 2. Ooh, so much work. Okay, so in the numerator, I have 4 square root of 5 plus 4 square root of 2 plus 2 times 5, square root of 10, 2 times 2, square root of 4. Ooh, I can evaluate that. So let's get back to that. On the bottom, I have just 5 minus 2. So that I have 3. This is 2. So that I have 4 square root of 5 plus 4 square root of 2 plus square root of 10 plus 2. That is our answer. Okay, that's it for rationalizing denominators. Section 6.5, more on division of radical expressions. Thanks.